Welcome to the Worldwide Center of Math. We're taking a look today at some of the basics of probabilities. Now, what we're often going to see with probability is wanting to calculate the probability that two events both happen, or the probability that one event or the other event happens. So the first that we're looking at is the probability that, say, A or B happens. This is pretty simple to figure out. It's the probability of A plus the probability of B minus the probability of both happening. Now, there's a special case for this. When A and B are mutually exclusive, meaning that they can't occur at the same time, we know that probability of A and B is going to be 0. So for mutually exclusive events, I'm going to abbreviate that ME. Probability of A or B is just probability of A plus the probability of B. So mutually exclusive events are going to be a lot easier to work with than normal events, because you don't have to figure out what that probability is. Sometimes it can be difficult to find out what the probability of A and B happening is. So we're just going to take a look at some basic examples. So let's take a look at one card draw, and we're asked to find the probability of getting a 5 or a spade. So the probability of getting a 5, there are 4 5s in the deck, so that's 4 out of 52. There are 13 total spades in the deck, so that's 13 out of 52. And then there's 1 5 of spades in the deck, so we need to subtract 1 out of 52. Because in that case, it is a 5 and a spade. And that can be reduced to 4 out of 13. So we're going to take a look at another example, this time with dice. We're going to take a look at the probability that a dice roll is less than or equal to 2, or it is equal to 6. So the probability that a dice roll is less than or equal to 2, well, there's 2 possible outcomes. It's a 2 or a 1, so that's 2 out of 6 total outcomes, plus the probability that it equals 6, that's 1 out of 6 total outcomes. Now we see that we don't have to subtract the probability that it's less than or equal to 2 and equal to 6, because that's not possible. So we just have 3 out of 6, or 1/2. So that's how you calculate OR probabilities. It's pretty simple to do, especially if you know whether or not the events are mutually exclusive. So we're going to take a look at counting the probability of A and B occurring. So this actually deals with conditional probabilities, which we're going to take a look at in the next video. But conditional probability is the probability of one event happening given that the other event does happen. So this notation here is the probability that B occurs given that A does occur times the probability of A. We can switch this around and have a conditional probability with A given B times the probability of B. Now again, we're going to have a special case, just like the mutually exclusive event over here. We're going to take a look at when A and B are independent, meaning that one doesn't affect the other. So whether or not you get an A, it has no effect on whether or not you get B. Just I and D standing for independent. So for independent events, the probability of A and B is just the probability of A times the probability of B. So we're going to take a look at just a couple more examples for and probabilities. So the first example we have is we have a dice roll and one single card draw, and we're asked the probability that the dice roll is less than or equal to 2 and that the card is a spade or a 5. So the probability that a dice roll is less than or equal to 2 is 2 out of 6. We have that 1 and the 2 possible outcomes out of 6 total outcomes. And now we need the probability that we have a spade or a 5, which we calculated over here as 4 out of 52 plus 13 out of 52 minus 1 out of 52, which equals 4/13. And the probability that we're going to get here is going to be 4 out of 39. Now the last example we're going to take a look at is some sampling with and without replacement. So basically that means that we're going to take a look at some independent and some dependent events. So say we have a box that has 9 marbles in it. There are 3 marbles of 3 different colors each. We have a red, a blue, and a yellow. So we're going to draw 3 marbles, and we're asked what the probability is that they're all blue, and we're told that the first 3 marbles are selected with replacement, meaning that after every marble draw, it's replaced. So since the marble is replaced, drawing the first blue marble has no effect on the second blue marble. So we have a 1/3 chance of getting the first, a 1/3 chance of the second, and a 1/3 chance of the third. We just multiply those all out. So we have a 1 out of 27 chance that all the marbles are blue if we're sampling with replacement. Now, if we're selecting 3 without replacement, we need to account for the fact that we have taken a marble out, and we're dealing with the conditional probability that we're drawing a blue, given that the first one we drew was a blue, and then the conditional probability that we're drawing another blue, given that the first 2 we drew were blues. So the probability that they're all blue with no replacement, well, the first one is 3 out of 9 are blue, or 1/3. Now, after we've drawn that first one, there's 8 marbles left. 2 are blue, so that's 2 out of 8, or 1/4. And then finally, there's 7 marbles left, but only one of the marbles left is going to be blue. So we have 1/7. So all we need to do is multiply 3 times 4 times 7, and we get a 1 out of, not 54. A 1 out of 84 chance that they're all blue without replacement. And that's how you calculate or and probabilities. We're going to take a look in the next video at how to calculate this probability here, the probability of B given that A occurs. Thank you for watching. For more math videos, please subscribe to our YouTube channel here. Or for additional resources, including affordable digital textbooks, please visit centerofmath.org.